Okay, I'm going to go over some different high points of your Unit 1 review to make sure you're ready for your test next week. On this first section right here, you are going back to days 1 and 2 of the semester and making sure you know how to do your function operations. So for example, on number 1, if I can make, you're going to start by doing g of x, and you're going to subtract h of x from that. So we're subtracting, we're doing 3x plus 1, and we are subtracting all of h of x, so it needs to be in parentheses. And then you'll combine your like terms. So on number 2, you're adding, 3 and 4, you're multiplying. So you're going to make sure you multiply those correctly. So as a reminder, you'll write them both in parentheses so that you remember you're multiplying the entire quantity. And here you're going to have to FOIL. So you're going to multiply your first terms, your outside, inside, and last. When you get to the second half, or these one with the open circles, this is where you will start doing your composition. So this was really from day 2 of the year, if you're looking back in your notes. And what that means is you're plugging the second function into your first. So I'm going to replace both x's in h with all of g. So when I write this out, it's going to be 2x minus 2 squared plus 2 times, and there's another x, another 2x minus 2. And again, you're going to do these operations all the way through. Do remember that when you are squaring anything, you're multiplying it by itself. So for that binomial, write it twice, and you're going to FOIL just like on number 4. When you get past that and there's a number in the parentheses, remember you're going to do the operation, and you're just replacing the variable with whatever the number is. Okay, so whether you plug the number in first or last doesn't matter, but you'll do the operation and then plug in that variable and get or plug in the number for the variable and get an answer. On 11, for our piecewise function, you're going to go through and match up your variable and figure out which of the functions you're going to plug it into. So here I was given 2 for my x, so I'm going to read through these functions and figure out what 2 falls into of these domain restrictions. 2 is greater than 1, so I'm going to plug it only into this function. You're going to do the same with the rest of them. So any number bigger than 1 or equal to 1, you'll plug into the bottom one, so the 4 and the 1. And then the other 2 you'll plug in wherever they do belong. So just read it carefully and make sure you figure out where each number goes. Looking at the second page, these first ones are back from day 1, where you are going to write an equation for me and then figure out what you will plug in. Remember that you do have the answer keys for all of these, so you can go through and check your equation and then make sure you're using it correctly all the way through. On the bottom, you're figuring out if 2 equations are inverses or not. And when you're doing that, you have 2 different methods to do it. You can either do your composition, and when you do that, you should only get an x for your answer, or whatever your variable is. If you get an x for your answer, then yes, they're inverses. Of anything else would tell you no, they're not inverses. The other thing you can do is you could take one of your 2 functions, so say take this top one right here, switch your variables, and solve for f. If my resulting equation here matches my g of x, then that means they are inverses. This is exactly what you would do on the next problem, so I'm going to show you it all the way out on the next ones. What it will look like on the test sometimes is that I will tell you to find the inverse of a function, so I won't give you both. I'll just ask you to find, ask you to find one of them. And then you're going to graph both of the inverse and the function. So say we do number 19. We're going to start by finding the inverse. I'm going to switch my variables. It's going to be n equals -1 minus 1/2 h. We're going to add 1. And then remember, I think of this as division. And so I'm going to go ahead and multiply by a -2, because that's negative. It's going to cancel out the 1/2. And then I'll have h of n, this is now my inverse, equals -2n minus 2. So this would be the inverse, and this is again what you could have done on the last problems also. or you have to do it when you're only given one equation. So to find an inverse, you always flip your variables and then solve. And then we're going to end up on this one graphing both of these. So if I graph my original function, I start at -1, and then I'm going to count down 1 and over 2, or up 1 and left 2, and draw that line. For my inverse, I'm at -2 with a slope of -2, so I count down 2 and over 1, and these will be these points. If you want an easy way to check your inverse problems, what you want to check is that it reflects over the line x equals y or y equals x. So this red part up here would reflect over to this on the green, and the green would reflect over the red, so that means I did find my inverse correctly. On the next ones, you're starting to talk about our function operations and how they translate or reflect or stretch. So what you want to make sure you're using, and I've mixed it together a little bit, but either your absolute value transformation form or your quadratic transformation form. And remembering what all of those things do. So I'll do a quick rundown of that for you here. Your A will stretch. If it is bigger than 1, it will compress. If it is less than 1 but bigger than 0, and it will reflect if it is negative. Your H will go left if you see a positive, so x plus 2 or something. Will go right if you see a negative. And then your K is up if there is a positive, or down if it is negative. This is what you have to know to be able to correctly write these equations given the information here. You will also use this on this page. On the top part, it's the same as the back. Here you're going backwards though. You're going to, given the equation, you want to be able to tell me what happened. For the next few, you're just graphing your different functions. So I'll walk through one of them with you. On your absolute value, you want to first find your vertex, as we do with most of ours. And your vertex is based on how it moved left, right, up, or down. So the x plus 2 tells me I went left. The plus 1 is up, so my vertex is at -2, 1. And that's going to go in the middle of your t-chart. We're going to plug to the left and to the right. And what we've talked about a lot in class was that you will have an axis of symmetry. So whenever I plug in either -3 or -1, my answers will match, as well as when I plug in either -4 or 0. So you do not have to plug in all the numbers separately. You just have to plug in 2 of them. When I plug in, say 0, 0 plus 2 is 2, absolute value of 2 is 2, times the 3 is 6, plus 1 is 7. Plugging in either -3 or -1, you're going to get a 1 inside your absolute value. So I will have 3 times 1 plus 1 is 4. Oopsies, and I went the wrong way on my graph accidentally. So -2 plus 1. So this is what my graph will look like. It is stretched and taller because of the 3, so that's good. And it went left and up. With this, remember we also did talk that you can count this slope as long as you are very careful not to give me a line. Be careful, that is the most common mistake. For my domain, you're thinking about how far to the left my graph will go as well as how far to the right. This line will keep going further and further to the left as it goes. Whoopsies. So it goes forever to the left as well as forever to the right. For your range, you're finding how far down it goes and how far up it goes. The lowest point of my graph here is at 1, and it will not go below that, but it does go up to infinity. Okay, I'll talk you through a quadratic as well to make sure that we are ready for that. But the process is, as we've talked about in class, very, very, very similar. So if we do number 33, let's see, I would go left 2 and up 3. So that means my vertex is at -2, 3. Your axis of symmetry is always through your vertex, so it's x equals -2. We're going to make our t-chart. And again, go left and right of that vertex. If you center it correctly, your graph is much easier to do. We also still have an axis of symmetry like we said before. So the -4 and 0 will match, the -3 and -1 will match. This is the same numbers as the last problem strictly because my x-coordinate and my vertex is the same. So don't assume that it will always have the same x's here. It will vary. When I plug in either -3 or -1, you should get out 2. When we plug in 0, we get out a -1. Which means I also get -1 at -4. Do make sure to draw this more as a curve. It needs to be not a V, but like an upside down U to make sure you get full points. Domain and range are the same idea. So domain is left to right, and this will go forever to the left and forever to the right. Range is bottom to top. So the lowest this graph goes is -infinity, and the highest is up here at 3. Okay, going to look at a piecewise function because that's what's next. I'll just pick one of these and walk through it with you also. If I do say number 38, first you want to find your boundary line. So it changes at -3 and at 2. So you pull whatever is over there in those inequalities. And I draw in my boundary line so that I know where I'm switching graphs. This isn't technically a part of the answer, so you do not have to draw them in if you don't want to, but I find that it helps. And then I'm going to make as many charts as I have equations. So I'm going to have 3 different charts here, one for -5, and remember you either color code this or you label it above. It doesn't matter, that's up to you. One for my middle one, and then I'll do my last one over here, x plus 1. And we need to think about what our boundary lines are for each equation. So for the -5, my boundary is the -3. So this graph is going to show up on this side of the line. It's where x is less than -3. It is equal to, so I'm going to draw a bracket, and I'm going to plug in numbers to the left of that, so for -4 and -5. For the middle one, it's between -3 and +2, so I'm going to put both of those in there. They're both parentheses. And we're going to talk in a second about picking numbers in there. But just to set up the last one, we pick 2. It is equal to, and then this one's easy again. We pick like 3 and 4. So for your y values, on my first chart, what this tells me is that all of my y values are -5. So I'm going to go down to -3, go down to -5. It is a closed circle, and it is just a horizontal line. When I plug in to the bottom one, so this one over here, plugging in 2 gives me 3, plugging in 3 gives me 4, and then 4 plus 1 is 5. So it is an a closed circle, at 2, 3. And then it is going up to the right. I can keep continuing points since it's a line. For the middle one, part of what tells me it might be trickier is that it is, a quadratic. So it's going to make a U. It needs to be a parabola of some sort. When I plug in -3, I get 4 minus -3 squared, which is 9. So 4 minus 9 is -5. When I plug in 2, I get 4 minus 2 squared, or 4, is 0. And if I look at that, it's not really easy to see. I know it should be curving somewhere, but my graph is all the way down here at first and then up here at 2, 0. And I don't really know what's happening in between. So on this one, we're going to actually plug in most of those values to get a better idea. Remember, I always encourage you to plug in more things if you are ever not sure what's actually happening here. When I plug in -2, 4 minus -2 squared is still 0. So that gives me another point. 4 minus -1 squared is 3. 4 minus 0 squared is 4. And then 4 minus 1 squared is 3. So that did now give me enough points to draw in my parabola. So just be careful if you're not sure what's happening. Always plug in more points and see what's going on. If it's a line, you're not going to have to worry about it as much because it will form that straight line for you and you can just count that slope. But with a parabola, it's going to be a little trickier. For my domain, remember you're checking to make sure that you could it goes forever to the left and right, as well as your boundary line. So we're going to extra check these boundary lines. On the first boundary line, my 2 points actually hit each other, but that means I can plug in -3, so that's good. On my second boundary line, I have an open circle and a closed circle. What's important is you have at least one closed circle. So that does mean my domain is -infinity to infinity. My range is bottom to top. The lowest my graph goes is here at -5. But I do get every y value out all the way up to forever. And so that would be your final answer. On your word problems, so they're going to be the same idea, but you're going to just also have to set up the equation. I'll walk through writing one of the equations, and then you can take care of doing the graphs. For this one, there's 2 different ways they're going to charge you for your cell phone plan. It's if you use up to 3 gigs, and then if you use beyond 3 gigs. So my function will have 2 different ways, whether x is less than or equal to 3, and whether x is greater than 3. Remember we talked in class that technically this is also greater than 0 because you're not going to use negative gigs. They're not going to charge you for using 0 gigs because that's just like not having a plan. If you use less than 3, you will pay this flat rate of $15. If you use more than 3, you still pay the $15, but you will add on to that $5 times every gig past 3. So you will not be charged the $5 for the first 3 gigs, but after that you will. So you have to do your x, which is your number of gigs, and subtract off the first 3 gigs so that this is only calculating the ones past it. So at your 4th gig, you're only paying an extra $5. At your 5th, you're paying 10. You can leave your equation like this, or you can distribute it through. If you distribute this through and combine like terms, you'll get just a 5x. Okay, remember on your chart, you can control your xy axis and whatever you want. You are welcome to ignore these lines if you need to, or use them if you would prefer. On your test, there will be no axes drawn in for you at all. Okay, on the supplement, I apologize, I meant to have this included as well in your normal review. So 1 and 2 are from your day 1.3. They're your absolute value equations, or inequalities. The first thing you want to do is isolate your absolute value, whatever that may be. So here we're going to subtract 8. And then divide by -3. When you divide by that -3, your inequality flips, and you get an 8. With absolute value, you always split it. One time when you split it, you do nothing but drop the absolute value bars. The other time when you split it, you flip the inequality, and you change the sign on the other side. So those rules always stay the same. But you also have to decide if it is an and or an or. Where you will look is right at the point where you split it. Here my inequality is greater than, so it is an or. If your inequality is a less than right before you split it, that's where it will be an and. But then you will solve both of those problems and graph it on a number line for me. This next section is from day 2. This is where I had you graph different functions where I did an operation to it. So for example, if we look at number 4, oopsies. It's telling us to do 2 times your h of x, which is x minus 6, and then add 6 to it. So I'm going to distribute that through. 2x minus 12 plus 6 gives me 2x minus 6, and that is really what I'm graphing. I don't care about the original thing, I care about this. So I'm going to go down to -6, count a slope of 2, and graph that line. Do make sure you're practicing your graphing if that's what you struggle with, because it does show up in a couple of different spots. Remember, you could always draw me a t-chart and figure out values if you're uncertain. On the last part, this is actually from your day 1 vocabulary. For a relation to be a function, every x value has to have exactly one y value. So if you have any y's that repeat themselves, or x's that repeat themselves with different y's, it is not a relation, or it's not a function, it's just a relation. For a function to be a 1-to-1 function, every x has one y and every y has one x. So go ahead and look through these. Remember that you do have the answer key for every single problem. You have the answer key for this last page on Remind, and then you have the answer key for the majority of the packet on the back. To receive 70% credit, remember I just expect you to complete the odds of the entire packet, and then I encourage you to go through and complete the extra ones that you need extra work on for more points. So focus on what you need to work on the most to be successful, so that your test will go as well as possible.